In this video, we'll be working through some examples to learn how to calculate the slope of a line, and we'll also learn how to use the slope of a line to help us draw the graph. In example A, we want to find the slope of the line that goes through 2 points, -2, -1, and 4, 3. From our last video, we learned that the slope formula is given by m equals y2 minus y1 divided by x2 minus x1. Let's treat -2, -1 as our first point. So we'll label this x1, y1. And let's treat 4, 3 as our second point. So we'll label that x2, y2. Once we've selected our first and second point, it's just a matter of plugging the correct numbers in the correct places to calculate the slope. So in our numerator, we have y2 minus y1. So the second y coordinate is 3. We're going to subtract the first y coordinate, which is -1. In our denominator, we have x2 minus x1. x2, our second x coordinate, is 4. Subtracting the first x coordinate would be subtracting -2. Doing some arithmetic here, in the numerator we have 3 minus -1. The double negatives turns into plus, so this is 3 plus 1, or 4. In the denominator we have 4 minus -2. Again, the double negatives turns this into 4 plus 2, or 6. Both the top and the bottom are divisible by 2, so we can cancel out that common factor, simplifying this fraction to 2/3. And that's it. 2/3 is the slope of our line. From our previous video, we learned that the slope can be thought of as the rise over the run. So when we have a fraction like this, we can think of the numerator as the rise and the denominator as the run. And what this means for our line is that if we want to get from one point on the line to another point on our line, we go up 2 units and we go across 3 units. Let's now look at our second example. Here we want to find the slope of the line that goes through the 2 points 0, 4 and 2, 3. And again, if we want to find the slope, we use the slope formula. M equals y2 minus y1 divided by x2 minus x1. Once again, we'll let 0, 4 be our first point, and 2, 3 will be our second point. So now let's calculate the slope. Our y2 is going to be 3. Our y1 is 4. So in the numerator, we have 3 minus 4. And then our x2 is going to be 2. And our x1 is 0. So in the denominator, we have 2 minus 0. Performing the arithmetic, in the numerator, 3 minus 4 gives us -1. In the denominator, 2 minus 0 gives us 2. So the slope of our line in this case is going to be -1/2. Once again, we can think about the slope as rise over run. So in this case, our numerator, -1, would be the rise, and 2 in the denominator would be the run. Which means that if you want to get from one point to another on your line, you would go down 1 unit, down because of the negative here instead of going up, and going across to the right 2 units. Again, if the numerator of your slope is negative, then that means you would go down instead of up. However, if the denominator of your slope is negative, you would go left instead of right. Now, before we move on to our next examples, let's look at the graphs of these two lines. In our first example, our line goes through -2, -1, and 4, 3. So our line looks like this. For our second line, we go through 0, 4 and 2, 3. Connecting these 2 points, we get the following line. So one thing to point out is that when your slope is positive, like in the first example, we see that our line goes up as we trace from left to right. On the other hand, if the slope is negative, like our second example, our line goes down as we trace from left to right. Next, let's look at calculating the slopes for horizontal and vertical lines. Looking at the examples from our previous video, we have the horizontal line y equals 3. Let's try to calculate the slope for this line. Once again, if you want to calculate the slope, we use the formula m equals y2 minus y1 divided by x2 minus x1. So let's select 2 points to work with here. Let's say that my first point is 0, 3, and my second point is 5, 3. Now, it doesn't matter which 2 points you pick. No matter which 2 you pick, you're always going to get the same result. So you could have picked -1, 3 and 2, 3 if you'd like. With 0, 3 as our first point and 5, 3 as our second point, our calculations are going to look like, well, y2 minus y1 would be 3 minus 3, and x2 minus x1 would be 5 minus 0. So in the numerator, 3 minus 3 gives us 0. In the denominator, 5 minus 0 gives us 5. And 0 divided by 5 is 0. So our slope in this case is going to be 0. Now this result that we got here should make some sense, because when we're dealing with horizontal lines, if we think about the slope as rise over run, to get from one point to another here, we don't go up at all, we just go across. So our rise will always be 0 for horizontal lines. And if the numerator is 0, then that means that the overall fraction is going to be 0. So in general, when you're dealing with horizontal lines, the slope will always be 0. This result should also make sense in the context of the steepness of a line. In our previous video, we saw that when the slope is large, we have a steep line. And if the slope is small, we have a shallow line. So when the slope is 0, that's when we have a completely flat line. Now let's look at vertical lines. Let's look at the example x equals 2. To calculate the slope, again, we're going to use the slope formula m equals y2 minus y1 divided by x2 minus x1. For our 2 points, we can choose 2, 4 to be our first point and 2, 1 to be our second point. Plugging the coordinates into our slope formula, y2 minus y1 would be 1 minus 4, and x2 minus x1 would be 2 minus 2. In the numerator, we end up with -3, and in the denominator, 2 minus 2 gives us 0. When a fraction has 0 in the denominator, we say that the fraction is undefined. So for the vertical line x equals 2, we say that the slope is undefined. Whenever we're working with a vertical line, all of the x-coordinates of the points that we have will always be the same. So when we do the calculation for the slope, the run, x2 minus x1, will always be 0 no matter which 2 points you pick. So in general, for vertical lines, the slope will always be undefined. Next, we're going to get some practice using the slope to help us draw the graphs of lines. In this example, we're going to draw graphs of lines that go through a given point with the given slope. So in our first example, we have the point 1, 2, and the slope m equals 2 over 5. If you want to draw the graph of a line, you'll need at least 2 points. Once you have those 2 points, you can just connect the 2 points with a straight line. What we'll do is we'll start by plotting the given point. So here, we put down the point 1, 2. Now, in order to draw the graph of this line, we need a second point. And so what we can do is we can use the slope to find that second point. Remember that the slope of a line tells us how to get from one point to another. The slope is the rise over run. So when we have a fraction like 2/5, the rise would be 2 and the run would be 5. This means that if we want to get from one point to another, all we have to do is go over to the right 5 units and then go up 2 units. If we start at the point 1, 2, if we go to the right 5 units, we'll end up at the x-coordinate 6. For the y-coordinate, if we start with 2 and we go up another 2 units, we'll end up at the y-coordinate 4. So a second point that would be on the graph of our line would be the point 6, 4. So again, all we have to do is start at the point 1, 2, go over to the right 5 units, and then go up 2 units, and we end up at 6, 4. And once we have these 2 points, all we have to do is connect it with a straight line to complete our graph. For our second example, we want to draw a line that goes through the points -2, 1 with slope -3. Let's start by placing the point -2, 1. And again, we're going to use our slope to find a second point that's on our line. In this problem, our slope is m equals -3. Normally, when our slope is a fraction, we can tell what the rise and run is by looking at the numerator and denominator. But in this case, our slope is a whole number. But remember that any whole number can be turned into a fraction, so -3 here can be thought of as -3/1. Now that it's a fraction, our numerator, -3, will be our rise, and our denominator, 1, will be our run. This means that if we want to go from one point to another on our line, we have to go down 3 units and go over to the right 1 unit. So starting at the point -2, 1, if we go to the right 1 unit, we'll end up at the x-coordinate -1. And for the y-coordinate, if we start at 1 and we go down 3 units, we'll end up at -2. So our second point will be at -1, -2. Again, all we're doing is we're starting at the point -2, 1. We went over to the right 1 unit and then down 3 units to end up at the point -1, -2. Once we have these 2 points, all we have to do is connect them with a straight line to complete our graph. So, in this video, we've learned how to calculate the slopes of lines when we're given 2 points. We looked at the slopes of horizontal lines and vertical lines. Remember that horizontal lines have slope equal to 0, and vertical lines have undefined slopes. And then we also use slopes to help us draw the graphs of lines. In our next video, we'll start talking about coming up with equations for lines.